This is a kind of a follow-up to the one I did, I'm not sure how many weeks ago, on events in JavaScript and kind of how events are handled in the browser and the event loop in particular. For anyone who's new to this one that did not attend the first one or who would like a reminder, the event loop is kind of how everything in JavaScript works to keep everything in sync between the JavaScript files that we write and how the browser handles things. When the page loads, the JavaScript renders, and if you use, for example, add event listener, what you're actually doing is that command goes to the browser and says, hey, dear browser, when you see one of these events come up on this specific event target, please trigger this function. And so it will sit over there in the web API section and wait and wait and wait and wait until that happens, at which point in time that callback function with the event as an argument gets passed into the callback queue, which it will then pass through the event loop here back to the JavaScript engine. The JavaScript engine, everything goes into the call stack, builds up, and can only come off the top of the call stack. And so when people talk about non-blocking code, that's what they're talking about, is keeping that call stack as empty as possible so that when new things come back in the callback, they can be run as quickly as possible. To that end, there are some events that we like to avoid to use. Under normal circumstances, some events can happen rather quickly. Here's a code pen. If you have the slides, you can open it here. I have it in the debug mode. If I can get my, there it is, open over here. So two events that run rather rapidly are the resize event. If you resize a window and you want to react to that, it happens very quickly. On the right-hand side here, you'll see the events as they pop into the console. Each event is logged individually, and then you'll also see the total number of times here as it goes. So just by resizing the browser window in the dev tools, we can see that we're running a whole bunch of events all at once. And you can see it's actually jittery a little bit because just by moving back and forth, we resized 64 times. And just the tiny load of, hey, by the way, can you also log each individual event to the browser or to the console, slows down the browser's ability to re-render that page as it's resized. So ideally, we don't want to do anything on resize unless we immediately debounce it or throttle it or in some way handle the aspect that we're going to get a bunch of events fired all at once. Let me pull this back over. And then similarly, scroll events happen very quickly. And so if I scroll on this, the scrolling happens exceptionally quickly, just down and back up, not even all the way down, but 103 events fired all at once there. And so if we were doing something like trying to keep something in the middle of the page there and not let it scroll, we would have to do that calculation and have the browser apply that logic 103 times just in that quick span. And so some events fire really rapidly. Other things, there aren't really events to handle. So this is from the Olivero page that Herschel set up on Tugboat. And one thing I want you to notice is as I hover over the drop-down menus, watch these list item elements over here in the dev tools. You'll see that as we hover, classes are applied and taken off. If we wanted to hook into that and figure out how we could react to that, there's not an event that exists for that. So we can't do everything we want to do maybe with just events. And so that's where observers come in. Observer APIs are providing another way to asynchronously watch for and react to changes of a target element or node or metric. There are three general purpose observers that I think we could probably start using in all websites today. As long as you don't need to support some ancient browser technology. And then there are two more that are more for web apps. And I'll talk about them, but I don't have examples for them because I've never used them and I don't feel terribly comfortable with them. They're not something that I think we will use in Drupal much at all. So the first one is the intersection observer from MDN. The Intersection Observer API provides a way to asynchronously observe changes in the intersection of a target element with an ancestor element or with the top-level documents viewport. What this is going to do is it detects the overlap between an observed element and some root element or viewport. You can only detect the overlap of something up that specific element's ancestor chain. So you can go to a parent, you can go to a grandparent, a great-grandparent, all the way back up to the window, but you can't go to at any point to a sibling. It doesn't work that way. You can't just watch for two, completely unrelated elements to interact that way. But once it detects that overlap, it triggers a callback method to run, and you can set it to run at one or multiple thresholds. So a demo here is just a quick page with images that are going to do some lazy loading and a couple of little extra effects. What I've done here is I've set it to watch for the elements to come into the page. And once they cross a threshold of 0, 50%, and 100%, will trigger some individual callbacks. So this is the page. And as we scroll down slowly, you'll also notice the intersection observers are also logged out individually. One thing I'd like to point out is on page load, the intersection observer, when it starts observing, immediately fires an observer entry. And we'll dig into those more in just a minute. But as we scroll, at some point, this image will change and start to look more like this one, and this one will start to change and look more like this one. And so you can see this one crosses the 0 threshold, and the opacity increases from partial to full. And then it loads in, and then we get the blue border. The one thing I wanted to show here is the aspect of the root margin. What we've got, and let me actually do this as well. When we are setting this up, this observer, what you're doing is you create a new intersection observer, you give it the specific callback you want to, and you can set it with some specific options. The root element by default is the document or the window, but you can set it to any parent of the element you want to observe. The root margin is just a string that matches a CSS margin string, and you are then expanding or constricting the area you want to watch for observation. So let me toggle this on. What we're actually doing here is we're coming in from the top 150 pixels, from each side 150 pixels, and from the bottom 150 pixels. And then the threshold can either be an individual integer or an array of integers between 0 and 1, indicating a percentage between 0 and 100%. In our callback here, we're then handling that, and then we have to pick each individual image and tell the intersection observer to observe that image. But then as we scroll, if I turn this back on, you'll notice as this one reaches the top of the margin, once it's not 100% inside, the border disappears. Once it crosses the 50% threshold, it goes back to the loader. And once it crosses the 0% threshold, it loses the opacity. And if I scroll back down and in, those reverse as they cross those same thresholds. And what's happening here then is if I clear this and I start scrolling back and forth real quick, the scroll event would fire rapidly, but this only happens as each element that we're watching crosses its decided root at the root margin, and then we can handle that accordingly. And so we can dramatically reduce the amount of times that callback method has to go through the JavaScript thread. Things that this is good for: handling elements based on their visibility in the viewport, or handling elements based on their visibility in the ancestor. Carousel slides are good for this. If you wanted to, for example, tell a video to pause play once you slide it out of view from a carousel, we're doing that in IBM right now. This is bad or useless for detecting intersections between laterally related elements, and by that I mean anything where you have to use a sibling relationship to get between what you want to observe intersecting. Or if there's something that you're going to have to handle this actually on every single scroll event. This would not be helpful for that. After that, we have the resize observer. The resize observer interface reports changes to the dimensions of an element's content or border box. So we're detecting changes to the element's bounding box, the actual size of an individual element. Then we trigger that callback, and we can set that one. That one is an error. We cannot set this one. I did not remove that when I copy and pasted the slide. This one is different from the resize event, mainly in that it works for all element types, whereas the resize event is only a valid event to listen for on the window being resized or SVG elements being resized. And the demo for that one is right here. What I've got here is just a div that has the ability to resize it. And so as I drag this around, you can see this one is also going to handle a lot of events. I mean, we've got a whole bunch of them over here. So this would also be something where you'd want to throttle that. However, this is not something that's firing resize events in the browser. So if you wanted to do something like this, you would have to figure out some other way to do it. And I'm honestly not sure if there's a great way to do it besides detecting mouse click and mouse drag as you resize this. Whereas now we have this nice resize observer entry, which has the content rect of the thing right there. You don't have to recalculate it. You don't have to go to the window and get the computed value. It hands it directly to you in the callback method. This one is good for responding to any element resizing, not just the window. And you could use this right now today to mimic what container queries will do in CSS when that lands and is widespread. Things to watch out for: still fires just as rapidly as your resize events. You'll want to throttle or debounce accordingly.
Hey, Andy, can you hear me?
Yep.
Do you know of any ways that you would throttle or debounce a resize event? Like, what kind of methods would there be? Is it just checking the width and height and seeing if it's resizing, or is there another thing you would want to do to throttle?
Yeah, no, that's a good question. So the resize callback from the observer is going to happen on every individual resize. If it changes a single pixel, it will throw that callback. There's not a good way to throttle it in the resize observer options. The way you'd want to throttle it is using something like a custom debounce or throttling function, which there is one in Drupal that you could pull from if you, and I'll find a link for that and add it back into this later. But it's good for both throttling and debouncing. And so you can just copy that one over. And I think, in fact, Drupal, I think, copied that from the Lodash library themselves.
Cool, thanks.
All right, the last kind of common one that I would talk about is the mutation observer. And this one is a little difficult to explain outside of, or difficult to demo outside of a specific scenario. The mutation observer interface provides the ability to watch for changes being made to the DOM tree. It's designed as a replacement for the older mutation events feature, which was part of the DOM3 event specification, which is now deprecated. So you may have seen up here this little asterisk. There are events that do this, but they are not well supported. They are not well implemented, and they have huge performance implications. So this one then detects changes to the DOM tree, triggers the callback method, and this one has some options that you can configure to run on specific types of mutations. And as I said, replaces the deprecated mutation events that had performance problems. The DOM tree, for those that may have missed the last one, I used this same image. This is how the browser views the page. It doesn't look at it as a document where it can read things. It's looking at how each individual node that it has to render relates to each other node, whether that's a child relationship, a grandchild relationship, whether that's an element or a text node or an attribute on an element. The mutation observer has some options, which I have listed here, as well as their defaults. It has the subtree option, where if I am going to observe, say, the HTML element, and I tell it to watch the subtree, it will also watch for the specified changes on everything that's in its child list. So it would watch the element, it would watch the element head, it would watch the element body. There is also, I'm sorry, that's child list. Subtree will also watch the entire subtree. So with subtree, anything that is in any way under the HTML, all the way down, all of these would be included. That is by default false. Child list is by default false, which is subtree, but only to one level. You can also tell it to watch for attributes to change, and you can filter those, and you can tell it to give you the old value of the attributes as well. This one you got to be a little careful about, because you can watch for changes on classes and respond to that by making a change to the class, and then you've got a recursion loop on your hands. So you do want to watch out for that and make sure you test and make sure you don't crash the browser when you start making these changes. You can also do character data. I've never used this one, but I would assume that is you could watch, for example, this element, this link, and say if somebody were to come in here and change the value of the link text here, that it would trigger the mutation observer, because this is just a text node in the DOM tree. So these are all the things that you can watch. Again, a demo. This one is a little bit weird here. So there's not actually anything on this page rendered, but if we come in here and we look in the body, we've got this div class root, and I believe I've got this set as, yes. So div root, I can do, for example, root.insert adjacent HTML, and I can put in here an h1 element. And as soon as I insert that, I've changed this element's DOM tree, and it will, cool, why did that not work? Insert adjacent HTML. Oh, because I got to tell it where. Before end. And so I've inserted this DOM node, and I get this mutation record of, hey, what just happened? We've got added nodes. It gives me a list of the nodes that were added. I can come in here and I could say root.classlist.add my class. And now I've got a mutation record type class. It will give me, looks like I didn't tell it to give me the old value. Oh, yes, I did. It didn't have. All right, let's try this. If we remove class, what happens, right? All right, so it looks like I'm not tracking the old value, so it's not giving me that. But this would be a great way if you were to want to hook into some other JavaScript that's running and you say, hey, when they add that class, also run this additional functionality. That would be one thing you could do. I'm trying to think of other things I've done. I've used this for, and nothing comes to mind immediately, but I know we've used it in the IBM project. So good for hooking into unrelated but highly predictable functionality. Again, you want to make sure that you're latching onto the right things that aren't going to change or be different from page load to page load. And you do want to watch out for recursion. You can create infinite loops by reacting to attribute changes, by making attribute changes.
Just a quick question. For the old value, I think I was reading on something before, but do you have to, I think there's something that you have to like say attribute, you have to activate the old attribute or something like that in order for it to.
Yeah. Yep. Okay. So you have to tell it to watch for attributes, and you have to tell it, give me the old value. Otherwise, it doesn't necessarily give you that.
Okay.
Yep. Good question. The last two here shouldn't take very long because, like I said, I have never used them, and I don't think that we will make a lot of use of them, but they are the performance observer. This is used to observe performance measurement events and be notified of new performance entries as they are recorded in the browser's performance timeline. So this is going to detect specific markers triggered within your code. These could be things like resources loading, resources called for, XHR requests, those kinds of things. And then triggering a callback method when those requests are made, when those requests get a response. This is mainly going to be useful for people who are making JavaScript heavy applications. If you're doing, an entire web app in JavaScript and you need to be able to monitor the performance. And honestly, I don't know if I would even have this on a production. That this might be the kind of thing that I would only want on a dev server where I can make sure that as we're working on it and staging stuff that we're not running into issues. And then the last one is the reporting observer. This one is still kind of new and is basically unsupported. The reporting API provides generic reporting mechanism for web applications to use to make reports available based on various platform features, content security policies, feature deprecation reports in a consistent manner. So this could be something where you could turn this on once on a site, and then as content security policy errors pop up as they would in the console, you could trigger a callback method to, for example, get that report sent back to Drupal and then log that in the watchdog reports on Drupal. But as I said, this is basically unsupported. It's very experimental, largely unimplemented in most browsers. This is something I could see being useful in the future, but at this point is not something that I would say we want to implement. That is it for my presentation. I would be happy to take some questions now on anything.
Hey, Andy, this is James. This is interesting. Thanks for sharing it. How nicely do these different observers play with one another if you have to use kind of more than one on a single element.
The only thing I could imagine causing an issue is if one of your observers triggered some change that then triggered the other one, and you kind of put yourself in a recursive loop. I don't think there's ever been an issue where I've had one interfere with another. Because the resize observer is only going to change when the element's DOM rect changes, and the mutation observer only fire when something in the DOM tree changes, and those aren't necessarily, that could happen if you changed a class, but then the class would change the resize observer first, and then when the browser got through the re-render, it would then trigger the resize one. Yeah. Unlike events, I don't believe these are cancelable. I think these just have to run. So you need to throw in, if you would ever need to bypass it, you would have to throw in some kind of if statement to check to make sure you actually wanted to run it.
One more question that I had was what's browser compatibility like for this? You might have already said this.
Pretty good. So the resize observer, all the evergreen browsers, not IE11. Mutation observer is in IE11. Intersection observer, evergreen, not IE. Opera Mini also does not support any of them. But other than that, pretty good. So, Drupal 10 could easily implement all of these in core. I did want to make sure John was on the call. John, did you want to talk about any of the kind of edge cases that we've run into, specifically that you've run into recently?
I don't know that I have a whole ton to add about it. The intersection observers and mutation observer that I'm using on an element have both played fairly well together. There's, I mean, for the particular issue I'm working on, there's an argument to be made that intersection observer was not necessarily the right call. Whereas compared to just a normal scroll handler, if you want to do dynamic animations or like positioning of elements based on what point in the scroll you're at, obviously you can't handle that with intersection observer because it calls it fires the callback once you've triggered your threshold. So yeah, if you need to constantly update the position of something based on the scroll, intersection observer.
You were mentioning to me yesterday that position fixed was also causing issues with your intersection.
That's true. So yeah, so I also had a situation where I was considering setting a second intersection observer within a table element, where I have an element within that table that gets set to position fixed, and I wanted to track the intersection of the fixed header of the table with the end of the table so that I could unset the fixed header, and that doesn't seem to work.
Yeah. So here,
because go for it.
In the demo here, I've got the image is what's being observed, and then I've applied fixed positioning to the figure element that's wrapping that. And as I move it up and down across that root margin, you can see it's not actually doing anything. So yeah, it looks like position fixed will break that.
Yeah, and I could be speaking out of turn here, but I think that has to do with the fact that once you set something to position fixed, it takes it out of the document flow, and intersection observer needs the elements to be within the flow to actually properly calculate the intersections.
Yeah. It does not seem to be doing anything like trying to do the math after it's rendered and done all of its layout and paint operations to figure out, okay, where is this thing actually? Is it actually intersecting? It looks to be doing that all before that.